something from outside our solar system, spent 13 months traveling through our cosmic neighborhood, and everything it showed us confirmed something that planetary scientists had quietly feared for years, that interstellar space is not the sterile, empty void that the standard models assumed. On July 1st, 2025, the Atlas telescope in Chile spotted 3I Atlas racing through our solar system at 68 kilometers per second, faster than any object born around our sun could ever travel at that distance. It was only the third interstellar object ever confirmed in human history, and from the moment it was discovered, everything it did was wrong. It was too bright. It switched on too early. It sprayed water at a distance where comets are not supposed to have enough heat to sublimate anything. Its methane levels were 11 times higher than any solar system object ever measured. Its trajectory was aligned with the ecliptic plane, the flat disk of our solar system, at a probability of 0.2% if its arrival direction were random. It lost 13% of its mass in a single p-arihelion passage. It had collimated jets so narrow and so structured that they looked more like engineered systems than natural geological venting. Every measurement confirmed the same terrifying conclusion, that the universe beyond our solar system is building objects with chemistry so foreign and behavior so extreme that the models built from studying our own solar system cannot predict or explain them. And what those objects carry inside them, the chemistry they bring from other stellar systems across billions of years of interstellar travel, has implications for the origin of life on Earth that scientists are still struggling to articulate clearly without sounding like they are making a claim they cannot yet prove. The water discovery alone rewrote what astronomers thought they knew about how comets behave. NASA's Swift Ultraviolet Optical Telescope observed interstellar comet 3I Atlas during 2 visits in July and August 2025, catching the first ever hint of water from such an object, detected through a faint ultraviolet glow of hydroxyl gas. Hydroxyl? Oh, is what you get when a water molecule is split apart by ultraviolet radiation from the sun. Detecting hydroxyl in the coma of a comet is detecting water. The discovery was already extraordinary because 3I Atlas was detected producing water at a distance from the sun, where most comets are completely inactive. The water ice on their surfaces is still too cold to sublimate. Even more surprising, the comet was blasting out water at a rate of about 40 kilograms per second, while still far from the sun, much farther than where most comets switch on, 40 kilograms of water per second, at a distance where comets born in our solar system are still frozen solid. The implication was immediate. Either 3I Atlas contained a type of water ice that sublimates at lower temperatures than normal water ice, or its internal heat budget was different from anything in our solar system's comet catalog. Either possibility pointed toward a formation environment with fundamentally different thermal history than any object that formed around our sun. Then came the methane. On June 26, 2026, a groundbreaking study published in Nature revealed that JWST's NIR-SPEC instrument detected a methane-to-water ratio roughly 11 times higher than any previously measured solar system object. 11 times, not 11% more. 11 times more methane relative to water than any comet or icy body that has ever been measured in our solar system. Methane ice is an ultra-volatile compound. It sublimates at temperatures around 30 to 40 Kelvin, roughly negative 240 degrees Celsius. At those temperatures, you're close to the coldest environments that exist in the vicinity of a star system, the outermost frozen reaches of the Oort cloud analog around another sun, where the star's radiation barely reaches, and temperatures have never been significantly above absolute zero. The methane-to-water ratio of 11x tells scientists something specific and quantitative about where 3I Atlas formed. It formed in a region so cold that methane ice could accumulate and survive for the billions of years it spent in interstellar space before entering our solar system. That cold region would be the outer Oort cloud equivalent of its birth star, a zone so remote from any stellar warmth that only the most volatile ices can exist there in stable form. And the Nature paper's lead author Martin Cordner at NASA Goddard noted that the staggering methane enrichment, driven purely by natural thermal outgassing processes, is unlike anything we have in our own solar system's catalog. The trajectory anomaly is the finding that most directly connects 3I Atlas to the fears that scientists have had about interstellar objects since the first one was discovered in 2017. The passage of 3I Atlas on a retrograde orbit within 5 degrees of the ecliptic plane provided an ideal opportunity for a spacecraft to intercept its path. That sentence contains a number that demands attention: 5 degrees from the ecliptic plane. The ecliptic plane, the flat disk on which all the planets orbit the sun, is aligned with the galaxy at a significant angle. Most objects arriving from random directions in the interstellar medium would arrive at steep angles to the ecliptic, not nearly parallel to it. The probability of a randomly directed interstellar object arriving within 5 degrees of the ecliptic is approximately 0.2%. That is not impossible. Unlikely events happen. But it is the kind of alignment that, in any other context, would prompt a statistical follow-up. Avi Loeb of Harvard University, who has been studying interstellar objects since Oumuamua and who cataloged 22 anomalies in 3I Atlas's behavior, listed this alignment as one of the features of the encounter. TH does not fit the expected profile of a randomly directed natural interstellar comet. The trajectory also placed 3I Atlas's perigove, its closest approach to Jupiter, at 53.6 million kilometers. Jupiter's Hill radius, the gravitational sphere of influence within which Jupiter dominates over the Sun's gravity, is 53.5 million kilometers. The comet passed at a distance almost exactly equal to the edge of Jupiter's gravitational influence, a coincidence whose probability Loeb calculated and described as remarkable. None of these anomalies individually constitute proof of anything extraordinary. But their accumulation, 22 separate features of 3I Atlas's behavior that deviate from the expected profile of a natural interstellar comet, is exactly the kind of pattern that proper scientific methodology requires to be examined rather than dismissed. The jet system that 3I Atlas exhibited during its perihelion passage was the most visually striking and scientifically unusual feature of its activity. Analysis of the Hubble Space Telescope image of 3I Atlas from July 21, 2025 suggests that the anti-tail before perihelion must have been in the form of a collimated jet towards the Sun that is about 10 times longer than it is wide. A collimated jet with an aspect ratio of 10 to 1, 10 times longer than it is wide, is not typical of natural cometary outgassing. Natural cometary jets are driven by the sublimation of volatile ices when they are exposed to sunlight, creating diffuse plumes of gas and dust that expand outward and are shaped by the comet's rotation and the solar wind into the broad tails that give comets their characteristic appearance. A jet that is 10 times longer than it is wide is collimated, focused, directed, maintaining its coherence over a distance far greater than diffuse sublimation would produce. Post-perihelion images confirmed that the jet structure persisted, extending to several 100,000 kilometers from the nucleus in a coherent structure. This morphology is extremely unusual for a natural comet. It is consistent with a highly concentrated volatile deposit on the nucleus surface, a specific regional concentration of ultravolatile material that erupts in a directed plume rather than diffusing across the entire surface. That kind of regional concentration could arise from how the comet formed, from the specific distribution of volatiles in its birth, environment, or from processes that occurred during its billions of years of interstellar travel. None of these explanations is fully worked out. The mass loss estimate of 13% during a single perihelion passage is the number that most directly connects to the fears about what interstellar objects bring into our solar system. 13% of 3I Atlas's total mass, shed as gas and dust into the space around our Sun during its closest solar approach, is an enormous amount of material. If the comet's total mass is approximately 44 billion kilograms, an estimate based on nucleus size measurements from Hubble, then 13% is roughly 5.7 billion kilograms of interstellar material, dispersed into our solar system's inner region during the passage. That material, carrying the chemistry of another stellar system, potentially including organic molecules, complex carbon compounds, and the volatile ices that contained methane at concentrations 11 times higher than anything in our catalog, is now mixed into the interplanetary environment. It will be swept up by solar radiation pressure, absorbed by planetary atmospheres, and delivered to planetary surfaces over the coming centuries. Not in dangerous quantities, not as anything that poses a threat, but as a chemical contribution from another star's planetary system injected into ours by the passage of a single interstellar comet in a single year. And if interstellar comets arrive at the rate that the discovery of 3 in 8 years implies, potentially 1 or more per year once Rubin Observatory reaches full operational capacity, then this kind of chemical delivery from interstellar space is not a rare accident of cosmic geometry. It is an ongoing process that has been happening for the entire history of the solar system. ESA described interstellar comets as absolutely foreign, true outsiders, carrying clues about the formation of worlds far beyond our own. The scientific fear that 3I Atlas confirmed is not that interstellar objects are dangerous. 3I Atlas posed zero threat to Earth, passing no closer than 270 million kilometers. The fear it confirmed is something more philosophically significant. It confirmed that the chemical isolation of our solar system, the assumption that the material making up Earth, making up the water in our oceans, making up the organic molecules that gave rise to life, is exclusively the product of our own solar system's formation, is not entirely correct. Interstellar objects have been delivering foreign chemistry to our solar system throughout its history. The methane, the complex organic molecules, the carbon compounds from stellar environments with completely different elemental abundances than our Sun, All of it has been arriving continuously, carried by objects exactly like 3I Atlas. And some fraction of the organic chemistry that made life possible on Earth may not have originated here at all. It may have arrived aboard interstellar visitors from star systems that formed billions of years before our Sun. A comprehensive SETI search found 0 radiotechnosignatures from 3I Atlas, and its unique chemical makeup is explained by natural thermal outgassing. It is natural. It is a comet. But what a natural interstellar comet carries inside it, and what it delivers when it passes through a solar system, is the most profound message that the universe has sent to scientists in the form of a frozen rock from another star. We are not chemically isolated. We never were. And 3I Atlas just proved it, one measurement at a time, from the moment it was spotted by a survey telescope in Chile until it faded past Jupiter and headed back into the dark. The statistical implications of what 3I Atlas revealed extend beyond its individual chemistry and trajectory anomalies to the broader question of how frequently interstellar objects of this kind pass through our solar system. Before 2017, the theoretical estimates for the rate of interstellar object detection were modest, perhaps one every few decades for objects large enough to see with existing telescopes. The discovery of Oumuamua in 2017, Borisov in 2019, and 3I Atlas in 2025, 3. Detections in 8 years implies that the actual population of interstellar objects passing through our solar system is far larger than those early estimates suggested. Simulations calibrated against the 3 confirmed discoveries now project that our solar system is continuously threaded by dozens of interstellar objects at any given moment, most of them too small or too faint for current telescopes to detect. The Rubin Observatory, now conducting its full survey from Chile, is expected to detect 1 or more interstellar objects per year once its full operational cadence is established. Within a decade, scientists may have dozens of confirmed interstellar comets and asteroids in the database, each one carrying the chemical signature of a different stellar environment, each one a data point in a growing picture of what the galaxy delivers, to solar systems through the constant exchange of frozen material between stars. 3I Atlas confirmed the fear that this exchange is real, that it is chemically significant, and that it has been shaping the chemistry of every solar system in the galaxy, including ours. For as long as stars have existed, the universe has always been trading. Molecules between stars. Scientists just did not have the instruments to see it happening. Now they do.